All right, let's get started with the class. But before we officially start, I wanted to put this out here again. This is a company that's going to be at the job fair, SGC Engineering. They're going to be on campus today and tomorrow from 5 to 7. And it's a wonderful opportunity to meet engineers who are looking to hire. So remember, you're all going to be, almost all of you will probably be going to the job fair in a couple of weeks. So this is an opportunity to go and meet these people with a heck of a lot less volume and noise. You can find out about the type of projects they do. You also get some free food, right? China Garden, not just a standard pizza fare. I don't know if anybody likes Chinese food, but anyway, it's a great opportunity. And even you folks from Power, right, who are all wrapped up in Power, and it's not a put down on Power, it's like just get an opportunity to meet other people, learn about different aspects of companies in Maine and whatever. You never know when you would want that opportunity to meet people. And so if you're going to go, I would say business casual. Don't wear a shirt with a suit. I mean, a shirt and tie, because, other people are going to be more casual. You're not doing interviews. You're just being professional. Okay. That's what they're going to be wearing. And if you're happy with your resume, it looks really good, I would bring a copy of your resume. All right. They have offices, the SGC electrical group, which I think this is a lot of the people are focusing on. They have offices in Bangor. They have office in Augusta, right downtown in Augusta. And then they have office right next to Target in South Portland, like not right next to it, within a mile there. So it's in the west, it's actually in Westbrook, but most people don't know, it's kind of more, it's closer to the mall than it is to downtown Westbrook. So if you're trying to get an idea where things are located. So they're kind of geographically spaced out. I think they have a couple people that work remotely in Presque Isle. So, there are options there in the long term. But yeah, you get to meet some different people and then form your own opinions about this particular company. So this is one of the benefits of being a student here, is that these people come to you, and this doesn't happen all that often. So if you have the time, you can do it today or tomorrow or both. Nothing wrong with going both. They might have different people. Okay. So I wanted to start off with that. Hope nobody felt like that was a waste of time. But yeah. Anyway, let's go over the test. Problem number 1. And feel free to ask questions when necessary. 20 ohm, 3 amps, 4 ohm. Another voltage source here, 25 volts. And now I gave you an unknown resistor and a voltage. So with this information, this problem is not possible to solve, right? Because you don't know what this value of R is. So you really would have no easy way of obtaining R and figuring out how much current would go through there. And then that means you can't figure out V naught. But one of the other things, if you looked on the slide or the handout, you actually had 2 amps flowing through from that power source. That was a measurement that was obtained to go ahead and do that. So immediately, what you should start doing is, what do you know? I know that 2 amps has to go through here. Oops, somebody has a question. Yeah, we'll get to that in a minute. But you know that 2 amps is going through here, which means 2 amps is going through here, which KCL means I've got 3 amps through here and 2 amps through here, which requires me to have 5 amps going through there. So in this whole section, there's 5 amps of current. But that's still not enough to be able to solve for R and VO. The other thing I needed to do is figure out what the voltage is across R. So how do I figure out the voltage? Well, I just do a bunch of Ohm's law. What's the voltage drop across the 20 ohm resistor, given you've got 2 amps through it? 40 volts, which means this point is 60 volts relative to ground. Then I drop another voltage here. How many volts do I drop through a 4 ohm resistor if I have 4 amps going through it? If I have 5 amps going through it, how much,
You said 4. You said 4.
Oh, yeah. 4 ohm resistor with 5 amps through it. What's the voltage drop going to be? 20. So at this point, this is 40 volts relative to ground. Then I do another plus to minus 25. So what is the actual voltage here? 15 volts. And now I know that 15 volts divided by 5 amps has got to be equal to R, which is 3 ohms. Should we punish him because he just admitted he came in a few minutes late and make him sit there and stew on it? No. There's no consequence, right? Arriving late. What's that? You do. And a mean teacher. Questions on number 1? Fair, unfair? Both? Sneaky, tricky? If you think it's sneaky, go back all the way to the beginning of the semester. And what did I say? The purpose of this class is to hopefully tighten your knowledge and understanding of circuit analysis. All we really did was do a combined KCL and KVL in the circuit, right? We didn't do any real mesh and nodal analysis, although you could have, right? You certainly could have done mesh and nodal analysis, but I'm like, you know what? I know the current, so I don't need to solve for the current. I'm just going to go ahead and start adding my voltage drops and end up with an answer. And that's what I did. Okay. Should we move on to number 2 or stay here for further discussion? Pretty straightforward, but not 100% straightforward.
Well, I didn't get all points, so
Wow.
apparently not.
Well, but I mean, what was the hardest part about this one? You were overthinking it? How? What were you overthinking?
Sounds right, but I personally tend to overthink.
Okay, so you don't have anything specific as to what you were overthinking. You just overthought it. Excellent. Thank you, Drew. So for those of you in TV land, one of your classmates said, I was thinking that 3 amp would have an impact on the 2 amp. Does it?
No.
Not at all. You've got 2 amps flowing out of that power supply. That 3 amp doesn't overrule, because that is an ideal voltage source. If you're telling me it's putting 2 amps out, all of a sudden I put the 3 amp in here and it's going to change things. No, it doesn't work that way. But it's just a KVL thing or KCL thing, right? You could just do KCL, a nodal analysis, and solve for that. When you overthink things, that means you're not confident in the stuff too, right? That's the other part of it. So be confident in yourselves. Let's do number 2. And number 2, I actually put on here to be like sometimes you do a gimme simple problem. I put number 2 as your gimme simple problem. That was my intention. Here's 3A. Here's, 5, not 15. Why am I writing 15? 5 ohms. This is plus to minus VR. Then I have a dependent source here. And this voltage here is 2 VR. So the question is solve for the source voltage, right? Okay, so is there anything you can do to make this problem easy? Because you see a dependent source in there, and oh boy, when we look at circuits with dependent sources, we run, right? Because those aren't easy. But just because it's a dependent source doesn't mean it's actually operating as a source. It could be a load. Remember when we talked about is power being absorbed or supplied? You can determine that based on the direction of current as well as the voltage. If it's dropping in the direction of current, it's a load. If it's rising in the direction of current, it's a source. So in this case, I know that 3 amps has to live through this whole series circuit. So that means that that 2VR dependent source is actually a dependent load. It's actually becoming a load. It's like a battery. It's absorbing power. So what is the voltage drop across the 5 ohm resistor? You got a 3 amp current going through a 5 amp resistor, 5 ohm resistor. What's the voltage drop? 15 volts. So VR is equal to 15, and we know that 2VR is equal to 30, right? So VS is equal to VR plus 2VR, or 3VR, which is equal to 45 volts. Now we just have to say power from the 3 amp source is V times I, 45 times 3, which is equal to 135. Is that correct? Now I have to say if it's absorbing or dissipating. Well, I mean, absorbing or supplying. Well, in the direction of current, the voltage is increasing. So it is supplying. And the P2VR, it's the same equation. It's the voltage times the current, which is equal to 90 watts. It is absorbing. Is it absorbing or supplying? It is absorbing because in the direction of current, the voltage is dropping. That's it for number 2. Fair, not fair? Tricky, sneaky? Was a dependent source that scary? Because I haven't done anything fancy, right? It's just like, well, I just look at the circuit. Same thing as problem 1. Look at the circuit, figure out how to do, take the knowledge of what you know for circuits and then apply it. Shall we move on to number 3? All right, another series circuit. And it's the problem says to solve for I and V out. Is there anything you can do quickly to solve for I? I what? I is given, yeah. It's a series circuit. So you know what I is, right? Then you start doing voltage drops. Now there's 2 ways you can do it. You can either take this voltage drop here, right? So you can do 12 minus I times 2, which is 4. And then 6, and I can end up with 2 volts, right? Right, not right? 24 volts, sorry. Do I have all the sign changes correctly there? So I can do the 12, and then I do plus to minus here. Wait a minute, where's my V out here? So minus to plus, 2 amps. Yeah, okay. So I can either do it here, well, let's just go ahead and do a full KVL here. So we've got V out is a plus to minus drop. Well, let's do it the whole Monty. So we'll start over in this corner and we'll do a loop equation to solve for it. So we have negative 12 plus 2 plus 4 plus 5, all of that times I, plus 6 plus V out equals 0, right? So V out is going to be equal to, let's see, I've got 6 minus 2 plus 4 plus 5 times I. No, because I moved those to the other side. I got negative 12 plus 6 is negative 6, and then I move it to the other side. And I think if you do that, you have negative 16 volts. Is that a problem? Negative voltage? No, not at all. That just means to tell me that the actual voltage is minus the plus here, which means it is a source. It's a current source that's actually as an actual source. It's not absorbing power. It's not absorbing power. It's supplying power. So that's why the voltage has to increase. Okay. Any questions on number about as mean as a box of kittens? I don't know if I marked the polarity wrong. It might be just a way, because normally when we do, loop equations, we always just do plus minus in direction. So based on our assumption, it was incorrect, but that doesn't mean it's actually incorrect. It just means well, it does mean it's incorrect. We just guessed wrong. That's all it is. Any questions on number 3? Too hard, too easy? Sneaky? Fair, not fair? People aren't saying very much. That's always a bad sign. What does that mean? Does that mean it was really hard? How come people aren't talking very much? Of this frustration with the test, or?
There. Right.
Well, so the general question is, why did perhaps people do poorly or not as well as they wanted to? How's that? That's a positive spin. Is there anything here that you didn't expect? That I asked you to do something that would have been like, wow, we have no way of knowing what this is. So what was the link or missing part, I should say, that made it so that you can do as well as you wanted? Practice more? You could have, but how do you practice more for this problem here, right? Like you just look at it, it's got to be 2 amps. If you understand how current flow is, you can certainly try practicing it, but this is just a basic understanding of that's a series circuit with 2 amp power supply. The whole circuit it has to be 2 ohm. So I don't know how you would practice this. This is just developing a deeper understanding of what's going on. And that's, again, the focus of this class, at least to this point. Okay. Any other comments or questions on that? No? All right. Let's go ahead and do number 4. Oh. Yeah, so the issue is, and I don't know if everybody agrees, the issue is sometimes recognizing what technique is most efficient to solve. So that's a very good point. I would challenge that a little bit, because is this really a technique? Like identifying I equals 2 ohms isn't really a technique, right? It's just, you just know that that's the case. So that's what we're trying to do, right? Just sometimes you do need to look at it, and that's when you have to have a deeper understanding of technique. Over here, it's more like just being able to see something and like, yeah, this has to be that way. And so that's where you overthink things, right? Saying there's no way it could be 2 amps. There's got to be something I'm missing. Oh my God, I don't understand anything about circuits. What am I doing in college? I should go home and sleep in my parents' basement. But you're overdoing it to yourself, because you do have the knowledge, you just don't have the confidence in your knowledge. And so maybe that's where the practice comes in, as you just get confident and like, yeah, this has to be this. That's all it is. But these would be perfect. If I was doing an interview, I would put these questions out there just to see some base level of ability of people. I would put questions like this saying, hey, can you show me what this means or how to do this? And it's not an interview is a process for, making sure they like you, but also like, do you have some technical aptitude? Can you work well under pressure, right? Because you're trying to be in your best behavior. All of a sudden, somebody throws something at you. And my first quote unquote real job, I went to an interview. I had no idea they were going to give me technical questions. And sure enough, they did. But they gave me basic circuit analysis questions that I was able to grind through, even though I didn't expect that those type of questions were going to be there. So anyway, let's continue. So this is 4 amps. This is 24. This is 12. And this is 10. And this is 8. So the question was, solve for V, which is the only voltage you have is right there, right? Because it's all the same voltage. So solve for V and the current through the 24 ohm resistor. So one circuit with a bunch of parallel stuff on it screams to do KCL, right? And nodal analysis if you can. So that's what I did. I said the current in. So the current in is going to be the 10 amps. Is going to be equal to the current out. So V divided by 24 plus V divided by 12 plus V divided by 8 plus 4. And solve for V. When I solve for V, I had 24 volts. And once I know that the voltage here is 24 volts, I can pretty quickly tell you that the I through the 24 ohm resistor has to be equal to 20. Questions on that one? Fair, not fair? Sneaky, tricky? Yeah, easy peasy, use KCL. Continue on to number 5. Because in my opinion, I thought 5 was the hardest problem to do. In my opinion. Because it was a lot of work. And it was a high probability for making mistakes. But interestingly enough, most of you all got it right. Which, I was like, wow, that's the hardest problem. Because there was a lot of logistical things in terms of setting it up. But let's get started. I have 20 volts. 2 ohms. 2 ohms. 7 ohms, I believe. 3 ohms. That's a 4-volt source. And then here in parallel, I have 5, 8, and 4. So, oh, wait a minute. I got to tell you, this is I1, I2, and I3. So our process to applying mesh analysis is sort of done a little bit for us because we know what the loop currents are. Now we just have to start applying our plus minuses in the direction of the current flow. Then you start writing your equations. So we'll start with the I1 loop, -20 plus I1, and I'm just going to combine these. Let me know if that becomes a problem. -2 I2 -2 I3 equals 0. My I2 loop, I have, let's see, I have -2 I1 plus, let's see, 5, 9, 11, 18 -7 I3. And then I've got to have the voltage source, so I've got minus to plus, which means that's a voltage rise. So that becomes a -8 equals 0. And my last equation, I've got -2I1 minus 7I2, and then plus 12I3. And into the direction of the loop current, it's dropping its voltage. So when I set it up in my matrix form, 28 minus 4 is going to be equal to 4 minus 2 minus 2 minus 2, 18 minus 7 minus 2 minus 7, 12. And solve for I1, I2, I3 by inverting your matrix. Question on number 5.
How exactly did you know what polarity is that? Or was that exactly the way this is plus minus?
Well,
If you went minus to plus.
so how I determine the plus to minus for like I1. So this current I1 is flowing in this direction. It's flowing this way. And a current flowing through a resistor has to drop voltage, right? It has to have a decrease in voltage. So the plus minus is because it's a load, right? Because resistors can't be sources. It's a load. So in the direction of current, that loop I1 current, it has to be dropping voltage. So it's prescribed because you assumed an I1 direction. So that's the reason why it shows up like that. Okay. Fair, not fair? Like I said, I thought this was the hardest problem on the test. Because it was the most prone for error, in my opinion. Number 6. I have another dependent source. And people really struggled with this one, and I'm not sure why. Because if you could do number 4, you could pretty much do this one as well, I think. So it says find the V, find the voltage. It's all you needed to do. So KCL, right? Nodal analysis. Assume some directions. So current in is 7. Uh-oh, I have a dependent source with a voltage on it. So what do I need to do? It's a dependent current source. So whose value is just V over 4. So you just add it in. It's not a voltage. It's shown as a current source. It's just a voltage. So all you have to do is say plus V over 4. That's going to be equal to V over 8 plus V over 3 plus 2. One equation, one unknown. Normally, when you have a dependent source, you have to write 2 equations, at least, one extra equation. But over here, you didn't need to do that. Is that not the right resistor?
I think it's
Oh, sorry. My eyeballs are. Yep, 6. I'm gonna clean my glasses, I guess. I'll get new ones. Fair, not fair? Again, I didn't think this was a hard problem because it was one equation. It wasn't like the previous problem where you had a ton of equations. I just had one equation. And it was just one node. So it was intended to be pretty straightforward. Want to go to the last problem? Is that a yes or no, or not sure? 0.8. 5. 2. And that's a 5 over there. Now, I'm not even going to bother showing the resistor there. Yeah, you can do a lot of redraws. I'm not even going to bother showing the load resistor because I'm looking at the Thevenin equivalent seen by a load. So I'm looking across that. So because I'm looking for the Thevenin equivalent voltage, which is the open circuit voltage, and really the Thevenin equivalent impedance, the very first thing I did was redraw the circuit, and I combined these two resistors right off the bat. Because I found it wasn't really all that helpful for me to keep them separate. And then I realized I could have certainly done nodal analysis at this point. But what I said is, well, if I solve for the Thevenin equivalent here, which is going to be equal to plus minus 0.8, 0.8, 2.5, and 2, I can just use voltage divider to get V open circuit, right? So V open circuit, or V Thevenin, is 0.8 times 2 over the sum of them, which is 5.3. And then to solve for my Thevenin equivalent resistance, I started with here, and I just turned off all independent sources by replacing them with their equivalent internal impedance. So that was an open circuit. And so what I see is our Thevenin, or our Norton, doesn't matter, is 2.5 plus 8 in parallel to 2. That was it. Fair, unfair? Oh, this one must have been unfair. Nobody wants to say either way, right? Anything unexpected, hard? Did you feel like you were prepared for the test? Is there something I could have done better up front? I mean, the idea was, again, just go through and basically review all the stuff. So no tricks up our sleeves, nothing fancy, was just intended to be fairly straightforward tests. And there were mixed results. Now, did anybody add up the total points that were on the test?
Yeah, I did.
Yeah, so you could have gotten more than 100 points on this test. So if you take your score and if you divide it by 100, that's your score. Does that get confusing? You could have earned more than 100% on this test. So if you got, let's say you got 105, your score on this test is a 105 out of 100. So you can get more than 100 points. I didn't ratio it based on the total number of points. I ratioed it basically going that way. Because one of the things I like to give people an opportunity to earn their points. And so this is a way of having you earn points. I don't like to work with scales. I don't like to do all this stuff because then you're just hoping for the curve. And it's like you're being given points. And to me, it's like I feel better when I earn them. And so that's the reason why we did it this way, or I did it this way. All right, I'll open comments up for folks. What do you got? What do you think? How do you feel?
I don't know if it was my brain, but I focused more, because they focus a lot on the mesh and all of the nodal stuff, where.
We focus more on the mesh, is that what you said?
I feel like that's kind of where we did, and that's where my brain went on most of it, so I tried to like revert to that, but.
See, I'm not sure I agree. I think we did more nodal analysis, right? Because I actually said I
Well, it's
prefer,
mesh and nodal.
oh, mesh and nodal.
Yeah. But I think that's when I kind of tried to do more of that, thinking it was more about that. Okay, something like that.
Well, that's a good point, but mesh and nodal are all based on KVL and KCL, right? So to be able to apply mesh and nodal analysis, you need to understand KVL and KCL. And that was pretty much all we did on this test, right? If you could do KVL and KCL and understand it, that was the intent. No other thoughts? But he's awfully quiet. That must mean disappointment.
It was a very, very tense, more disappointing, so, yeah.
So are you saying, so the disappointment, but if there's enough of you, then there's something that I didn't do correctly, right? And I don't know how to help fix that. I mean, we can certainly have more problems, but the idea with this test is not to just problem you to death. Because it's not about practicing KVL and KCL. It's like, do you have the understanding of the concepts? And usually the best way that I would do that is I would read. And remember at the beginning of the semester, I said, when you do your homework, go ahead and try to explain it to yourself. Because if you can explain it to yourself in your own words, that helps with understanding. The problem with just doing problem after problem after problem after problem is you just do a process. You don't necessarily understand 100% of the concepts behind it. I find that and this is for me, I'm talking about personally, is I find that I just understand, okay, this is the process. But what I'm trying to develop is, do I understand what's really happening here? Like, do I understand the basic concepts of KVL, KCL, and that type of stuff? That's what I'm trying to accomplish. Because if I really just wanted you to be able to do problems, that's more of a 111 or 312 type class, because that's when you do problem after problem after problem, because you're trying to get proficient at this. In this class, we're really just doing a basic review to get a deeper understanding, and then we very quickly venture off and start doing more advanced circuit analysis techniques solving differential equations, essentially. But I always think it's really good to do this review, because I do think it's necessary to make sure everybody is on the same page. Because for the most part, in this class, we're going to be writing equations based on our circuit analysis, and then we're going to solve them with differential equations. We don't have to do that here, because we're not looking at resistors, inductors, and capacitors. We've only done resistors, so there is no differential equations to solve. But what we'll see in the next class is we got to start solving differential equations. So I keep yapping, and I want to hear from you all. Is there anything I can do better? Are you feeling like maybe after the first test, okay, we can't get the vibe of what the tests are going to look like? They're really not that hard. I just need to believe in myself, maybe is the right way to say it. Be more confident. That's fair, or is that hard? Is that what you said?
Well, no, that's fair.
Okay.
Always puts me here on objective and fact.
Yes. And that is how your brain works too, right? Your brain kind of understands it, but it kind of doesn't. So that's why you lack confidence in yourself. Like, is it this or is it this? But be confident. I know this has to be the case. I'm sure of it. And so when you take off from that point, it just gives you that clarity. How about anything from TV land? We've had a bunch of comments from Arthur. Thank you for that. Anybody else in TV land? I know there's a gaggle of you.
I think that, like, I'm not sure who it was, but we focused a lot on nodal and mesh and doing the process of nodal and mesh. So going into the test, I was assuming that we were going to have more of those processes.
So are you saying then that because of the way the problems were asked, it was confusing you?
No, not how the problems were asked, but how we worked up until the exam. It was a lot of doing nodal and mesh equations. Like, yes, the problems on the exam were about the concepts, but we're doing the process instead of kind of jumping back and forth between learning concept and process.
Okay. That's fair. I will just add though that I wasn't really trying to teach you new concepts. It was a review, right? So not to argue with you, I'm just pointing out like this was all a review. Should have been a review is what my intention was. So we didn't delve into the concepts as much because I think all of you have seen all this material before, right? So hopefully it was to ring a bell, but that's good feedback. Thank you, Brandon. Anything else from TV land or? Okay, well, one of the rewards I give you is I always do an exam review. Back in the day, I used to never do exam reviews. I would just start pounding new material, but I'm trying to make it so that you guys get a reprieve. So we won't have any more class material, even though we got a bunch of time. But I will let you go early or we can stay and chat, whatever. But we'll pick up new material on Thursday. So any other comments, thoughts, suggestions? Nada? All right, y'all. Have a great day. I will see you all on Thursday. Or maybe some people go to the job fair tonight. Hopefully you go. Tell me how it went. Take care, everyone.
All right,
Have a-
see you later.
Thank
Hey,
you.
Paul, can I
Yes.
talk to you for a quick second? Are
Um,
you in your,
Huh?
what was it? Could I talk to you for a quick second?